All right, this is lesson 5, adding and subtracting rational expressions, part 2. So we have to remember our methods from lesson 4 to add or subtract rational expressions with denominators that are not monomials. So in the last lesson, if we just zip back to it, you'll see that all these things are just kind of like one term, right? There's nothing crazy going on. You know, it even might be variables, but it's still just one term in the denominator. Well, today we're going to be dealing with things that are not monomials. So binomials multiplied by monomials, we're going to get a real mix. So the first example here, if you do notice that this term is the same. So if they're the same, just go ahead and add or subtract the numerators. Now, if you think of this as a term, if we're subtracting, that negative symbol is going to be distributed to both of those. So you have m minus 4 minus m plus 10, and the denominator is just going to stay the same. And if you collect your like terms, the m minus m gives me nothing. Negative 4 plus 10 leaves me with positive 6 over m minus 2. And our non-permissible values, m cannot equal 2. All right, well, this one's different. These are not the same term, okay? So if they're not the same, the lowest common denominator here is actually x multiplied by x plus 4. So what you're going to do is you're going to multiply this term by x plus 4, and you're going to multiply this by x. And what happens here is you get 5x plus 4, don't know why I have an extra bracket there, over x and x plus 4 plus 6x squared over x and x plus 4. So now we have a common denominator. So you can collect like terms. And if we collect like terms, you're going to get 6x squared plus 5x plus 4 over x and x plus 4. Okay. Now something to note, you can't factor this one. So we're just left. We're stuck at this stage. So that's simplified. And our non-permissible values, x cannot equal 0 or negative 4. Because if you put a negative 4 in here, that's going to equal 0 there. All right. Let's try another one here. This one's a little sneaky. The common denominator here is actually a plus b. A is the same as a over 1. So if we're subtracting these two, you're going to have to multiply this term by a plus b. Okay? And so you're going to get a squared plus ab over a plus b minus 3 over a plus b. Well, let's collect these like terms now, and you end up with a squared plus ab minus 3 over a plus b. And you can't factor the top, so this is as far as we're going to go. And your non-permissible values are a cannot equal negative b. All right, this one's a little tricky because there's no numbers on the bottom. But if you recall from lesson 2, if you take that, whatever that denominator is, and set it equal to 0 and then solve, it just can't be the negative version of b. Because if you substitute in that, you'd get negative b plus b, which then gives you 0. All right. So the lowest common denominator here, we've got x minus 5 and x minus 2 as two terms. So the lowest common denominator is actually the product of those two. So the one on the right, we need to multiply by x minus 2. And the one on the left, we have to multiply by x minus 2. And the one on the right, we're going to multiply by x minus 5. All right, it's going to get a little messy here, but let's focus on what's going on here. So we've got to FOIL that. So you get x squared plus 3x minus 2x, so plus x, minus 6 over x minus 2, x minus 5. And then we're going to subtract, and the numerator here, if we FOIL these two terms, you get x squared minus 5x minus 7x, so minus 12x, whoops, and we're not done. And then negative 5 multiplied by negative 5 gives me positive 35 over x minus 2, x minus 5. All right, now we can collect like terms. So the numerator, we're going to get x squared plus x minus 6. Now this negative is now going to be distributed. So minus x squared plus 12x minus 35 over top of x minus 2, x minus 5. And if you collect some like terms, x squared minus x squared gives me 0. What else we got? Positive x and positive 12x gives me 13x. And negative 6 and negative 35 gives me negative 41. And my denominator is x minus 2, x minus 5. Okay, and non-permissible values. X cannot equal 2 or 5. Frequently, we must factor the denominators so that the lowest common denominator can be more readily determined. So look at the denominator here. If we change this to 2 and x plus 2, and if we change this to 3 and x plus 2, well, it's a little bit more clear, maybe not a ton more clear, but a little bit more clear as to what's going on here. So if we actually think about the lowest common denominator, that would be 6 and x plus 2. So the left side, you're going to multiply this by 3, and the right side, you're going to multiply it by 2. You're going to double it. So on the left side, you would end up with 21 over 6x and, sorry, not 6x, 6 and x plus 2. And on the right side, you'd end up with 10 and 6x plus 2. And now you can collect like terms, and you're going to end up with 11 over 6 and x plus 2. That won't simplify any farther. So our non-permissive values are x cannot equal negative 2. Now I'm going pretty quick through here, so you can pause, you can go back and slow it down if you need to. All right, so we got a real mess going on here. We've got 3 different denominators. Okay, let's just try and simplify some stuff. If you notice this term here, that would be the same as negative a plus 3. And if you factor out the negative, you'd end up with negative a minus 3. Okay, so let's just keep that in mind. And over here, this looks like a difference of squares question. So if we factored that, you'd get a plus 3 and a minus 3. Okay, so let's just rewrite this stuff with rearranging the denominators. So b over, and we're going to change this one to that form. And this one is going to stay the same form. And the last one we factor first to see what's going on here. Okay, well that looks a little nicer. And let's just focus on this. You can put the negative in any spot. So it can go there and it's still the same value. It can kind of go in the middle and it's still the same value, or you can apply it to the denominator and it's still the same value. So I'm going to apply it to the numerator. So the whole term is still negative. but the denominators look a little cleaner here. So if you can see what's going on, the lowest common denominator is in fact a plus 3, a minus 3. That means we need to multiply this one by a plus 3 and this one by a minus 3, and this one, the last one, is conveniently already in that form, so we don't have to do anything to that one. So let's see what happens here. So the first section here, that's what we're going to focus on. We're going to end up with negative AB minus 3B over a plus 3, a minus 3. The second section here, we're going to end up with AB minus 3B over a plus 3, a minus 3, and the last one remain unchanged. So we're good there. All right, let's go ahead and collect some like terms here. So this negative is going to apply to both of those. We're going to get negative AB minus 3B minus AB plus 3B plus 1 over a plus 3, a minus 3. Okay, it will get nicer. Negative AB minus another AB gives us negative 2AB. And then we've got negative 3b and positive 3b, that just becomes 0. And then we've got the positive 1 hanging out at the end. Okay, and our non-permissible values, a cannot equal plus or minus 3. Okay. Pause the video. I want you to factor the denominators of both of these terms here, these polynomial expressions, and see what the denominators come out to be. So if you factored these correctly, you're going to get 3x plus 2 and x plus 2. And the one on the right is going to be 3x plus 2 and x plus 1. Okay, so you'll notice that this part's the same for both, so that's handy. The x plus 2 is on the left side, but it's not on the right side. And the x plus 1 is on the right side, but it's not on the left side. So what you're going to do is you're going to multiply the left side by the missing term, and you're going to multiply the right side by the missing term. So over here, we're getting the x plus 1. And over here, we're going to multiply by x plus 2. Well, I used the wrong highlighter color. It's the pink stuff. All right. So the numerator on the left side here, if you FOIL this, if you expand it, you will get 2x squared minus 6x minus 8 over, and then you've got 3 sets of brackets in your denominator now. X plus 1, 3x plus 2, and x plus 2. And then if you expand the numerators on the right side, you're going to end up with x squared plus 5x plus 6 over top of the same 3 terms. Now we can collect our like terms, and you're going to end up with 3x squared minus x minus 2 and all 3 terms again. Now, we haven't run into this situation where we can actually factor the numerator again. So this is why the factoring skills are so important, because you can factor this, and you're going to end up with 3x plus 2 over x minus 1 over top of 3x plus 2, x plus 1, and x plus 2. And those terms will actually simplify, and your final expression is x minus 1 over x plus 1, x plus 2. And don't forget about your non-permissible values. X cannot equal -1, -2, and -2/3. Okay, and we're taking it from this stage. When possible, the sum or difference should be reduced to lowest terms. Okie dokie. So first of all, let's factor these denominators to see what we're working with. And the left side here will become x minus 6 and x minus 3. And the right side will become x minus 6, x minus 4. Okay, so it's handy that the x minus 6 is common to both, but the right side is missing the x minus 3, and the left side is missing x minus 4. Okay, so the LCD is actually all three of those terms multiplied together. Okay. All right, so expand the left side, the numerator. So you get x squared minus 4x, and that's over top of all three of those terms. And expand the right side. So you got x squared minus 5x plus 6 over top of, again, all three terms. Okay. And now we can collect like terms. And don't forget that this negative is going to distribute to all three of these. So minus x squared plus 5x minus 6. Again, we still have all three of those. And can you collect any like terms? The x squared and the negative x squared will simplify. And negative 4x and positive 5x will just go to x. And then we've got the negative 6 hanging out there. And if you look at the bottom, the x minus 6 will simplify to 1. So don't get caught out here. Your numerator is still 1. And your denominator is x minus 3, x minus 4. My non-permissible values, x cannot equal 4, 6, or 3.